Good morning, Haley.
Good morning.
Slow start today. I just got on, and usually there's like a bunch of people, bing, 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 right away. But we'll see. I'm sure more people will come. There's one right now. Good morning, Christopher. Should have written down the plan for today. Just review today, though, basically. Homework questions. Oh, speaking of homework questions, I should get the homework up. Get that ready to go in case there are any homework questions. And then I also have the review document up too. Cool. All right, this was the one that I had a hard time. Is it 4.7 or 4.8? Like the book didn't work, the ebook didn't work. 4.7 was fine. It was 4.8. I tried to open the ebook and it like stopped halfway through the chapter. It's weird. All right, now I think we're pretty ready to go here. Reminder of the schedule. Today we're going to go over homework questions and then some exam review. I did post the key to the practice, the study guide, and we can go over the study guide if you like, whatever questions you have today, and then the exam will be posted later today. I wrote in the schedule after class. Technically that will be true. I'm glad I didn't write immediately after class because it will not be ready immediately after class because I'm still working on it. So the exam will be posted later today, and then it'll be due tomorrow. We'll have tomorrow to work on it. I did change my plans a little bit for the exam, and because of some of the stuff going on in this section, I think you should make a formula sheet. So I added that on the top of the exam. I want you to prepare a formula sheet. So it can be one page, handwritten, and then whatever you want to put on your formula sheet. So that can kind of relieve some of the anxiety we had talked about last time about some of the antiderivatives and how much do we have to memorize, how much do we not have to memorize. So you can have a one-page formula sheet for this one, which means the questions they're not just going to be, find a simple derivative. There'll be a little more to them because you have the derivatives and antiderivatives in front of you. But that'll kind of make things a little bit easier for that. So one-page formula sheet for the exam, and then I'm going to ask you to include that with your upload. So add that to your upload. So let's do this. Let's do, are there any questions about what will be on the exam? Let's start with that. What you need to know for the exam. All right, I'm not seeing any questions. Feel free to pop in the chat later or unmute yourself. Let's talk about maybe homework next. Does anyone have any questions that you wanted to ask from the homework?
Can you go over number 15 from section 4.7?
Sure. I need a new page here. All right, so 4.7, I've got that up here. Number 15, these are the optimization problems. So this one, let me look here. Find the coordinates on the parabola that are closest to a specific point. This one is kind of cool because we should be able to graph this when we're done. Why does it not let me resize it? I don't understand when it does this. All right, a little bit smaller. we should be able to graph this when we're done and graph the equation, graph the point, and we should be able to visually check, does it look like that's the closest point? So that's kind of cool. All right, I'm going to do a quick graph sketch of this. We've got the parabola y equals x squared, like so. All right, and we have the point 2, 1/2, so this would be 1, 1, right? That's on the parabola. So 2, 1/2 is right here. All right. And let's see, we're trying to find the point on the parabola that is closest to that point. So it's got to be, if we draw, we'll do it in red here, it's got to be right around here somewhere. And let's call its coordinates xy. And we are trying to minimize the distance. And I have a hint for you here that will be helpful. We've talked about it before, but it just once kind of quickly in passing. You know the distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. The square root of that, that's just the Pythagorean theorem is all it is. It's a triangle. And so we could find the distance formula here between these 2 points. That would be x minus 2 squared plus y minus 1/2 squared, and the square root of that. And so we could minimize that equation right there. There's 2 issues that I see here. One is this is not a formula, this is a function of 2 variables. So we need to do that process. That's something we usually do. We have to figure out, what can I do to get this to be a function of just a single variable? Does anybody have any ideas how we can change this to get this to be just a function of x or just a function of y?
Y equals x squared.
Right, everybody see that? Because we have because my xy is on the graph, y is equal to x squared. So now I have distance, and the distance now is a function of x. So that's good. The distance is now a function of x. And I could find the minimum distance. I don't really want to though, because it's got this whole thing inside a square root, so you'd have to do a big chain rule. So here's a little hint. I don't know if you already thought of this, Christopher, but for everybody else, minimizing the distance squared is equivalent. So if you find the smallest square distance, that's the same as finding the smallest distance. And the benefit of that, distance squared, is you don't have a square root. And that's going to be a lot easier to optimize, to take the derivative, set it equal to 0, etc. So I'm going to call that just a function f of x. You can square all this out if you like. It's up to you. But you'll get a polynomial if you do that, and then you can just take the derivative of that polynomial, or you can take the derivative the way that it looks. I think eventually we're going to have to expand it all to solve. So why don't we go ahead and expand it right now? X squared minus 4x plus 4. X to the 4th minus x squared plus 1/4. Is that right? That looks good. And so f of x will be equal to x to the 4th minus 4x plus 4 1/4. So all of this work we've done so far, there's actually no calculus here. This is all algebra. And that's usually the foundation for these. We've talked about that. It's typically the setup, the algebra, the getting a function of one variable to differentiate that is usually the challenge on the optimization questions. So, does anyone have any questions so far? Especially, Christopher, I know this was your question. Are you good so far?
Yes, I'm fine.
Anyone else have any additional questions? Okay, I'm not seeing any. Feel free to jump in at any point and interrupt. It's funny how, I don't know if you feel it, I definitely feel it. I don't know if you've noticed, I like to, when I ask questions, I actually have a little counter in my head where I wait 10 seconds. I did that in class too. And you kind of in person, you see me looking around, I can kind of gauge what's happening. And then here, when I wait 10 seconds, it's just like, it's really awkward. It's like really just silence. So I do just still want to wait though, because I know some people might be typing or whatever. So, but it definitely feels awkward. Okay, now we're ready to optimize this function. So let's take its derivative, 4x cubed minus 4. Set that equal to 0, factor out a 4. Well, that's convenient. We get x is equal to 1. And we know y is equal to x squared. That is really sloppy, x squared. So y is also equal to 1, so it must be the point 1, 1. So my graph's a little bit off there. Oh, I know why my graph is off. I'll show you why. Right, it looked like my point was going to be here. That was going to be the closest, but that's because of my scale, because I didn't have a square scale. Let's graph it. I have a Desmos window up because I knew we were going to need it. And we'll graph y equals x squared. Let's zoom in here. I'll come back to the work there in a second. But there's y equal x squared. And we have the point 2, 1/2. And then we have the point 1, 1. Right? Looks good. Looks to be the closest point. Makes sense to me. So let me go back to the work. There's just a couple of quick calculus steps there at the end. Not much calculus. I mean, actually, technically, one calculus step. One. Right here. There's the calculus. Okay. Any questions on that one? Lorenzo, go ahead. You're still muted. There, you're unmuted, Lorenzo. Go ahead.
Oh yeah. So I'm confused why the d squared went into an f of x.
Just a labeling choice. It's just a function, and it's like it's the function for whatever the distance squared is. And so I just wanted to call it something that I could take the derivative. It just felt awkward to call it a d squared function of x. Just like weird notation. So I just called it another function. It's just a function. It's just a function that we're trying to optimize.
All right.
Yeah.
What happened to the d squared?
That's what Lorenzo was asking here, and it just became f of x. I'm just going to let d squared be the function f of x.
So you don't do anything with the square part?
Nope. It's just a function. It happens to represent the square of the distance, but it is just a function of x. Yeah, it feels weird, right? Doesn't it feel like we should do like a chain rule or something with it? I totally get it. If you'd rather, you can certainly take the derivative of the distance. And that will get you the same answer when you're done. It will be a lot more work. So we squared the distance to get this d squared thing. And we just said, you know what? That's a function of x. So I'm just going to call it f of x. And then I'm going to find where is the smallest distance squared? Where is the smallest f of x? So,
Okay, so you made d squared equal f of x, but
yes.
if you wanted to get d by itself, you would have to square everything, correct? Because that's only d squared. So to get d,
here's the thing. So let me show this. Let me do this. Let's graph the distance. Okay, let's graph the distance function. So d equals, and it was square root of what was it, x minus 2 squared Oh, I have a weird, sorry, x minus 2 squared plus, and then what's x squared minus 1/2 squared. And you'll notice where that is a minimum is at 1. When x is equal to 1, the distance is a minimum, okay? Now let's graph the distance squared. So I'm just going to call that my f of x. And that will be just, actually I can just go up here and copy this stuff under the square root. Okay. There's the stuff under the square root, and you'll notice it looks different. It's a different function. However, its minimum is at the same x value. So these two functions, the distance and the square of the distance, they look different. However, their minimum occurs at the same x value. So all we were looking for is what is the x value where the distance is minimum. And the logic there was that the distance will be minimum at the same x value where the distance squared is a minimum. And all we needed was the x value. We don't really care what the distance is, so we don't need to be squaring it or taking a square root or any of that. That's not relevant. It's just asking, where's the point? What is the x value where the distance is minimum? Does that help at all?
Yes.
This is, I don't know. It all makes sense in my head. I think it's not a clear thing at all. So I think it's understandable if there's a confusion. Any additional questions about that one? I'm glad you brought that one up, Christopher. Any additional questions on that? All right, that was a good one. What other homework questions? Maybe let's stick with 4-7 since I had that one open. Any additional 4-7 homework questions?
47.
All right, 47. That's a big number. I'm a little nervous. 47. All right, how do I turn this off? There we go. All right, let's grab this. Okay, all right, I have not done this one. I really don't understand why. I think it's a monitor resolution thing. I think that's why it pastes in so big. Okay, let's take a look here. Picture 4 meters in height is hung on a wall with the lower edge 3 meters above the level of an observer's eye. How far from the wall should the observer stand in order to obtain the most favorable view? That is, the picture should subtend the maximum angle. I don't even understand the language there. The picture should subtend the maximum angle. We need to look up what subtend means. Does anyone know? Can't even spell it, subtend. Trying to look here. Let's look at a picture. Let's see if that helps. Oops, sorry. Angle subtended by arc CD from point A. So I'm trying to figure out, I think there's an angle in here that we're trying to maximize. The question is, which angle is it? Because there's 2 possible ones, right? It's either this angle or this angle. I think it's the picture. So I think this is theta. Does that seem right?
Yes, I have the upper one is theta.
Uh-huh.
Lower one is theta 1.
Yeah,
And then
some other angle.
combined, they have theta 2.
Hmm.
So
And
I
then
left it.
we have a distance from too. That's going to be relevant, like how far from the wall. Hmm. And let's draw kind of, we look at it from the side. We have an X, we have a theta, we have 3 and 4. So I would like to get an equation involving just theta and X. In fact, I'd like to get theta. I'd like to get, oh, go ahead. Oh, Chantal, did you have a question? Or, no? So I'd like to get, because I'm trying to optimize how far from the wall. So I'm trying to get the most favorable view of the picture, the maximum angle. So I'm trying to maximize theta. And so ideally, I'd like to get theta as a function of X. So I'm trying to think of an equation that we can get that would involve just theta and X. Now we do have this triangle right here that has 4 and theta in it. It's not a right triangle though. So we can't use the regular trig functions there. I know that this one is the right triangle, the bottom one is, and we can certainly find the other side. It would be square root of 9 plus x squared. And so I feel like somehow that's going to be useful. And just to save us some time here, I'm going to just cheat a little bit and look up some hints here. This is definitely not one like we had done. It's a very different setup. Did you get any further than this, Christopher, or is this about?
Yes, I didn't do the square root of 9 plus x squared. I just did I had a combination of theta 1 and theta 2, and it was theta equals theta 2 minus theta 1, and I had a ratio between the two. So it was tangent theta 2 equals 7 over x, because I had both of the form. And that was theta 2 equals tangent, inverse tangent 7 over x, and theta 1 equals inverse tangent 3 over x. So in the long run, it came out theta equals tangent, inverse tangent 7 over x minus inverse tangent 3 over x. And that's as far as I have.
Yeah, it seems pretty good. Yeah, that makes sense to me. So let me take a look here, see. Oh, I'm in the wrong section. Oh boy. So this this homework set is one that was recommended. There's a committee of my colleagues that said, hey, this is a good general homework set that you might want to try. And so I just kind of copied the default homework set that everyone did. This is, you can kind of see what Christopher's getting at, that this is really pretty similar to what he had set up. I do not think that this is valuable for us to look any further than that. So I will just applaud your valiant attempt and then make a note for myself to remove number 47 for next semester. So I appreciate the valiant attempt, Christopher. This one does not look like it's worth us investigating. It's pretty challenging. If you want to take a screenshot of this, you can see how the textbook did it. Kind of take a look at that. If you just do like, if you have a Windows computer, you do Windows key Shift S, and then you can snip that. Yikes. But you can see how you've got do you see the 7 over x and 3 over x in there? And so you might have had an equivalent approach to it that's different from theirs, but that would also work. I just don't, and right now I don't think it's worth our time to investigate. We could maybe do that outside of class if you're interested. But that's brutal. Whew. Okay, back to homework here. We will skip that one for now. Are there any additional homework questions from 4.7? All right, 4.8. There's like something weird happening with the book, so you might need to like read it off to me, because I try to go down and then it like just stops and I can't go any further. So I can't get the rest of this section. I don't know why. So if you have one, maybe if you can type it in or just read it off to me from 4.7, I'll try to copy it as best as I can. 4.7 was about the antiderivatives. So maybe we should be able to write those. So what do you have from 4.8, I mean? So anybody have any from 4.8 that you wanted to ask about?
Yes, I have one.
Go ahead.
Is ds over dt.
Which number is this one, Christopher?
41.
Okay, all right. So ds dt, good, equals?
T to the third plus 1 over t squared when t equals 1 and s equals 2.
Okay, so we kind of have the 0.12. Gotcha. All right. So what I like to do when I have powers here is just rewrite them with negative exponents if necessary. So t to the negative second. And you have to think of your power rule, your derivative. The derivative with respect to t of t to a power would be n times t to the n minus 1. So when we go backwards then, if ds dt equals t to the power a, then we would reverse that process. S, well, normally you would multiply down and subtract. So now you're going to add and then divide. That's the reverse process when you're doing the antiderivative. You do the process in reverse order. So normally for the derivative, you would multiply by the exponent and then subtract 1 from the exponent. So for the antiderivative, you have to go backwards. You add 1 to the exponent and then divide by that new exponent. That's what we're going to do here then. We will add 1 to the exponent, so t to the 4th, and then divide by 4. And then add 1 to the exponent here, t to the negative 1 over negative 1. And then there could have been some constant there because the derivative of a constant is 0. So there could be some unknown constant, at least unknown at this point. Okay, so I did the negative exponents to help me do the antiderivative. Now I'm going to rewrite it back in a more comfortable algebraic form. 1/4 t to the 4th minus 1 over t plus c. And a lot of this is personal preference. I like the negative exponents to take derivatives or do antiderivatives, so I rewrite them with negative exponents for that. And then I rewrite them back with positive exponents to do things with, to do some algebra or solve or evaluate or whatever. Okay, now we know we have the point when t equals 1, s equals 2, or another way you could say that is s of 1 equals 2. And so that just means I'm going to plug 1 into my function, 1/4 times 1 to the 4th minus 1 over 1 plus c equals 2. And then I'll just solve for what the c is.
Could you go over that again?
Yeah, so what we're doing here is we have, I'm going to erase all that. I'll write it again. We have our function. Are you okay with that? You okay to there?
S, but I just plugged 2 in for S. That's why I went wrong, I guess.
No, it's okay. Yeah, that's what I'm doing too. I'm plugging 2 in for S and then 1 in for T. S of T is a function, but you could think of it as just S. Right? It's representing S. It's like y is a function of x equals something. You could say f of 1, or you could also just say 2, because y is f of 1. Like they're the same thing. So I wrote it as s of 1 equals 1/4 times 1 to the 4th minus 1 over 1 plus c equals 2. But that's the same as plugging in 2 for s. Does that, I don't know, does that clarify what you were getting at, Christopher, or does that?
Yes. Thank you.
Okay, okay, yeah, no problem. Let's go ahead and finish. 2 equals 1/4 minus 1 plus c. 1/4 minus 1 would be -3/4. So c must be 2 3/4, or what would that be? 8/4 plus 3/4, 11/4. So s of t equals 1/4 t to the 4th minus 1 over t plus 11/4. And this is a pretty common question. I was working on the exam thinking what things I should ask from this section. And I was thinking like at least 2 questions. One, maybe 1 or 2, just find the antiderivative. And then 1, like find the general antiderivative. And then 1 like this, where you find the specific antiderivative, where you have to be given a point. And then you use that point to find the c. And this is a pretty typical level 1. We'll see one kind of like this on the test. Any additional questions on that example? Number, was what, 41, number 41 from 4.8?
Yeah, I'm kind of confused how you got to where it's the t to the 4th over 4. I don't know how you got to it equaling 1/4 t to the 4th.
Well, just think of it like, it's a good question. So if you have, let me just do a simple one here. See, I have 18 divided by 2, but I want to write it as a multiplication problem. So 18 divided by 2 is really half of 18. So that's equivalent to saying 1/2 times 18. So that's all I'm doing here, is saying, well, dividing by 4 is taking 1/4 of it and just writing it as a multiplication problem. That's all.
Oh, okay. Then
Yeah,
I'm sorry.
no, you can do that anytime. If you have a divided by b, that's the same as 1 over b times a. Those are the same thing.
Then how did it become -1 over t? Oh, because it's t to the negative first. Okay.
And then the -1, all that does is just make it a subtraction.
Yeah.
Mm-hmm.
Okay.
Yep. Yeah, good question. All right, anybody else? Any additional questions? All right, are there any others from 4.8 that you wanted to ask about? We have a question for number 45. Brittany, you're gonna have to somehow, like, I don't have my book with me, and because I figured I'll just have the ebook, and for whatever reason, this section will not open for me. So I don't know if you can just read it off to me, maybe. You're unmuted, but I can't hear anything. She's working on it. It's awkward. I have no idea why that one section wouldn't work. I mean, I can open up the answers. Maybe we can figure out what the problem would be from the answer.
Can you hear me?
Yes.
Okay, perfect. I'm so sorry.
No, it's fine.
So I have d squared y over dx squared equals
Mhm.
e to the x when x equals 0, y equals 2 when x equals 1 and y equals e.
Like that?
Yes.
Okay. So good question. First of all, we have to know what in the world that d squared y over dx squared means. So does anyone remember, can you remind us what that actually represents? Or if you know, Brittany, you can answer too.
That's like the second derivative?
Yeah, that's the second derivative. So if it helps, I don't know if do you like the prime notation better, Brittany? With the little,
Yeah, it's a little easier just to kind of keep it. I've been using the f, so the f's make more sense right now.
okay. So that's what we have here. That's the second derivative. So what this means is working back one step, f prime of x is the antiderivative of e to the x. By the way, wouldn't it be nice to have a notation for antiderivative so we don't have to write that out?
Yeah.
Just wait until Monday. We'll get that next week in 5.1. Or no, 5, it's coming up. It's coming up. Okay, so do you know the antiderivative of e to the x, Brittany?
Oh man. It is e to the
Yeah.
e to the x
E to
so
the x.
plus c.
Yeah. Yep. Because the derivative of e to the x is e to the x. So the antiderivative of e to the x is e to the x. And you're right, there could be a c there. Now here's the challenge. It'd be nice to know what that c is, but I don't have any information about what f prime of something is. So I need to go one more step right now. F of x is the antiderivative of e to the x plus c. Let's call that c1, in fact.
Okay.
Now we already know the antiderivative of e to the x. That's e to the x. What is the antiderivative of c1, a constant?
C1x.
That's right, Christopher. c1 times x, right? If you take the derivative of that, you would just get c1. And I almost have f of x now. There's one more part to it. Anybody know what I'm missing?
Plus another c.
Another c. That's why I labeled it c1, because there's another c here. We'll call it c2. So now I just need to figure out two different c's. And that's why if you look above, they gave you two different pieces of information here. That's not coincidental. You have two unknowns, so they gave you two pieces of information. So let's see, when x was 0, y was 2. So that means f of 0 equals 2. So e to the 0 plus c1 times 0 plus c2 equals 2. That's using the fact that when x was 0, y was 2. So I put in a 0 for x, and I set the f of x, the y, equal to 2. c1 times 0 would just be 0. E to the 0 is 1. And so c2 must be 1. Now I know f of x is e to the x plus c1x plus 1. And now I can use the second fact. F of, what was it, 1 equals e?
Mm-hmm.
When x was 1, y was e. F of 1 equals e. So that would be e to the 1 plus c1 times 1 plus 1 equals e. So e plus c1 plus 1 equals e. We can subtract e from both sides, so c1 must be negative 1. And there we have it. F of x or y is e to the x minus 1x plus 1.
I thought that you found the first derivative, which was e to the x plus c, and then you plug in x equals 0, y equals 2.
That's why I
But-
messed up.
Just to find
Yeah,
both
but unless that would only be if Brittany read that wrong and it said if x is 0, y prime is 2. But she said when x is 0, y is 2. So that's not y. This is not y. This is y prime. Now it could have been, again, I'm sorry, I don't have the text in front of me, but if it said when x is 0, y prime is 2, then you would be correct. Can we clarify what it says?
It says that when x is 0, y equals 2. It's no primes in either.
Yeah, yep. So that's not why. So I like your thought. It makes sense why you would do that, but that is not why. That's not why. You have to go two derivatives, two antiderivatives to get back to y. Yeah. Yeah, the notation is important here. Because you started at the second derivative, one antiderivative gets you the derivative, and then another antiderivative gets you y.
To avoid the confusion, would it be better just to stick with the same notation as is in the problem?
It depends on you, on the individual.
Yeah.
So I'm comfortable enough where I can mix and match, and I can use the d squared y over dx squared. I can use y prime. I can use f prime. And so it's kind of up to you.
So when do you decide where to place the variables for x and y?
Yeah, I have to get a y. I had to keep going until I had a y. So I had to get to here. This is y. So that's kind of to Brittany's point. Maybe we should have done y prime and y double prime instead of the f prime, because it kind of confused us what we were talking about. So I had to get to y. I had to do two antiderivatives to get to y before I could plug anything in. So it depends on the information you're given. There is no one answer. Here's what you always do. If I had a different problem, totally different problem, and I said, oh, well, when x is equal to 0, y prime is equal to 1, and then when x is equal to 1, y is equal to 2, well, then if I start with y double prime, I can do one antiderivative and get y prime, and I can plug in 0 in for all that and set it equal to 1, because the information I was given was about y prime. But on this question, I wasn't given any information about y prime. I was only given information about y, and so I had to go two antiderivatives before I plugged anything in. I had to get all the way back to y. So that's a good question, Brittany. Christopher, does that clarify it for you?
I believe so. Just so I'm clear, you're going to be plugging those separate variables into the same equation?
Correct.
Okay. All right.
Yep. And the reason why we needed 2 here is because we had 2 unknowns, C1 and C2. So however many unknowns you have, in fact, if you're given the second derivative, you need 2 points. You need 2 things to plug in because you're going to have to figure out 2 different constants. Good, good, good. Any other homework questions?
47.
All right, let me get some workspace here. And can you read that one off to me?
A of t equals negative 32 feet per square.
Yeah, feet per second, yeah.
S of 0 equals 0 feet. V of 0 equals 150 or 180, 128 feet 128 feet per second.
Per second, sounds good. Yeah, so this is very similar to the last one. Acceleration is the second derivative of position. So what we really have here is S double prime of t is negative 32. So we need to go back twice. So getting the velocity is S prime of t. So that's one antiderivative. Velocity is the derivative of position. We have this, we're given the second derivative. So we need to go backwards to the first derivative, which would be negative 32t plus some constant. We'll call it c1. So the key is we're given acceleration, and acceleration is the derivative of velocity. So if we want, we're going to have to eventually go back to position, but we have to do the velocity first. And this one, unlike the previous one, we were given information about the derivative. Everybody see that? We're given the information about the velocity, so I can actually do that right now. V of 0 equals 128. So that's negative 32 times 0 plus C1 equals 128. So C1 must be 128. So the velocity function is negative 32t plus 128. We're going to just repeat the process. So let me pause here. Anybody have any questions about how we started with acceleration? And I'm changing notation. Instead of calling it acceleration, I'm reminding myself that it's the second derivative of position. So then I did one antiderivative to get v, plugged in my given information, and now I have velocity. Any questions on that process?
So you're not going to have, because I started off with 32t, and then I went to negative 16t squared.
We'll get there. We'll get there, but we're starting with just negative 32 because that's what was given to us.
Okay, all right.
Mm-hmm. Yep. Any other questions?
Does there need to be a C after the 128?
No, because we're not done. So there was a C in the V originally because we took the antiderivative. And you could check here, right? V prime will be negative 32. And then the 128 will just be 0. And that's perfect. That's the second derivative.
Gotcha.
That's acceleration. So that's good. Right now, though, now let's get position. So this will be the antiderivative of the velocity. And this is where Christopher was getting at. We have t. We're going to add 1 to the exponent to get squared, and then we're going to divide by the new exponent. And then 128 would have been 128t. And then there's another constant there, call it c2. And if we clean that up a little bit, that's where Christopher was saying negative 16. So it comes, the negative 16 does come, but it's in the position. Negative 16t squared plus 128t plus c2. And now we have the other condition. It's just off screen here. S of 0 equals 0. S of 0 equals 0. So that's negative 16 times 0 squared, that's 0. Plus 128 times 0, that's 0. Plus C2 equals 0. So C2 is 0. So then we have it. So the position S of t is negative 16 t squared plus 128t. So this ties back into Brittany's question, where this one was different. We were given information about the derivative this time. So we did substitute in after the first antiderivative. Whereas with her question, we had to do both antiderivatives and then plug in twice into that. This one was different because of the information we were given. Because we were given information about velocity, we could then use that to find the first constant. Any questions on that one? All right. Let's talk about the study guide here. I did post a key that I did quickly last night. So hopefully it's all correct. Did anyone, I have a blank copy here that we could go over too. Some of these are harder than others. So I mean, we have time. We got about 15, 20 minutes left here. Does anybody have any requests that you wanted to? By the way, I'm going to be available all the way until noon. So if you have additional questions, I'm happy to stay on. Did you know in the chat that you can send a private message to me? So if in the chat you can go to, then you can click on me. So if you say, hey, Professor Crenlaw, I want to talk to you like for after class or whatever, just send me a message or shoot me an email, and I can help you with more. But we have about 15, 20 minutes left here. Does anybody have anything from the practice exam, or from the study guide that you wanted to talk about?
I have a question on number 1 from the related rates problem. Just, you don't have to go over the whole thing. I was just wondering how you solved on the side, because you did 17 times 3 and then 65 plus 1 times 3. So I was wondering like why you did that.
Yeah, let me do a quick sketch just to set it up for everybody. So you can download the key, it's there. If you look at this, we have a triangle. And what did I just do X and Y? I think I did, didn't I? I'll just try to do the same thing that I did before. Yeah, X, Y, and R. Okay. So we'll call this X, we'll call this Y, call these R. Those are all changing. You can see the balloon is increasing at 1 feet per second. So dy dt is 1 feet per second. Sorry, my kids are like, can I? They were holding up little muffins and say they're like, can I eat one muffin? And then the bicycle is moving at a constant rate of 17 feet per second. So dx dt is 17 feet per second. And what Haley's getting at is eventually we actually need to know what X and Y are. We need to know what they are. And so the problem is, it says, how fast is the distance between the bicycle and balloon increasing 3 seconds later? It doesn't say how fast is it increasing when the distance is a certain number of feet. It's saying 3 seconds later. So the key is the balloon is rising vertically at a constant rate. So 3 seconds later, if it's going up at 1 feet per second, it would have gone up. It started at 65 and it went up 1 feet per second for 3 seconds. So then it's 68. And if the bicyclist is traveling at a constant rate of 17 feet per second, well, 3 seconds later, so balloon is rising vertically. Just when the balloon is 65 feet above the ground, a bicycle passes under it. So here, this is t equals 0. And then here, this is t equal 3. And so 3 seconds later, at 17 feet per second, it's 17 times 3, which is 51. So all I did there was just assume those constant velocities and just multiply by 3 seconds to get those distances. Does that answer your question, Haley?
Yes, thank you.
You're very welcome. All right. Then Brittany had a question about 13 and 14. Oh, yeah, these are the hardest ones. Oh, Lorenzo, do you have a question about the one we were just doing?
It's not number 1, it's number 2.
Okay, all right. So we'll do that one next, okay? So Brittany, the key here is, I think 13 is easier than 14. The reason is 13 is giving you the graph of f. So all you have to do is describe the function of f. You need to give me one moment here, sorry. So I find it easier to just describe the function f rather than 14 you'll see is a lot harder. So the function f, we can just kind of mark some key points here. We can see we've got some key points that are happening there where the derivative is 0 at all those points. And then there's some points where the concavity changes. You can see it's concave down, and then it switches somewhere around here, and then it's concave up. And then it switches again, maybe somewhere around here to concave down. And then it switches again at this point to concave up. So I'm marking all of those inflection points on the graph. These are inflection points. So increasing, decreasing, I just read off the graph. It's increasing up to -1, and then it's increasing from about 1/2 to infinity. The rest of it here, it's going up, it's going up. And then it's decreasing in the middle there from, you know, about -1 to 1/2. And those are just approximate. You're just guessing from the picture. So as long as you were close there, if you put like 3/4 or something, maybe it does look more like 3/4, it's fine. It's not a big deal. Then there's a relative max. You could put the point, or you could just give the x value, x equals -1, relative minimum at x equals 1/2. And then concave up, there's this concave up here. So from, I don't know, -1/2 to 1.5. And then where's that next one? 3 to infinity, maybe? Concave up over here, concave up, concave up. And then concave down up to the first inflection point, so -infinity to -1/2, and then 1.5 to 3. So it's curved downward here, concave down, and then it's curved downward here, concave down. And then you can see I have the 3 inflection points marked on there. So we said approximately -1/2, 1.5, and 3. So this is all about reading the graph and reading increasing, decreasing, and then the curve for the concavity, concave down versus concave up. So any questions about 13? Okay, 14 is harder, and this was one that we had on a quiz, was similar to this, where the problem is you're not given the graph of the function, you're given the graph of the derivative, yet you are asked questions about the function. So here's the key. The function is increasing when the derivative is positive. Well, where is the derivative positive? The derivative is positive between -2 and 0. And then the derivative is positive from 1 to infinity. If you like, you could make even a little first derivative chart. It's 0 at -2. It's negative before then, so decreasing. It's 0 at 0. It's positive, so the function is increasing. It's 0 at 1 and negative in the middle, and then positive after that. And this is all just reading the x-axis above the x-axis, below the x-axis, positive, negative. So then decreasing from -infinity to -2 and from 0 to 1. And then you can see on the first derivative chart, this is really messing with you. You want to say relative maximum here at that peak, but this is not the graph of the function. This is the graph of the derivative. So we want to know, when does it stop increasing? And it stops increasing at 0, and then it starts decreasing. So there's a relative maximum at x equals 0, and then relative minimums at x equal -2 and x equal 1.
Can you please explain one more time about the relative minimum and relative maximum?
If you think about a regular function, you have a minute, let's do a maximum. So it goes up and then comes down. And here's your maximum. And so the key is, before that, the function is increasing. So f prime is greater than 0. And then after it, it's decreasing. So f prime is less than 0. So I'm looking for, on the derivative, where does the derivative change from positive to negative? On my chart, I have it right here at 0. The derivative went from positive to negative, but you can see it on the graph. Remember, this is the graph of the derivative. So where does the derivative change from positive to negative? Right here. Positive, negative. So that means the original function must have a maximum there, because the derivative went from positive to negative. The original function went from increasing to decreasing. Does that help, Sandra?
Yes, so the key is to know the logic, like when it's changed from positive to negative, you have a max and stuff like that.
Yes. Okay. Yes. And I think, I don't know if this helps you, it definitely helps me to make a chart of the first derivative. And then I basically ignore, I'm like going to cover my hand up over the other, as if you can't see it. But then I basically ignore all of this and just look at my first derivative chart.
Okay.
All right, now here's the hardest part, in my opinion, is trying to read the concavity from the graph of the derivative. Okay, so you really need to know the meaning. So to be concave up, that's where it maybe curves like this. The key is, if you look here, the slope is increasing. F prime is increasing. So what we need to do is we need to look at our graph and look at where is the slope positive of our derivative graph. We're going to make an F double prime graph. And so this is the slope of the F prime graph. So the second derivative, the concavity, is the slope of the first derivative. So now I'm kind of really messing with you here. Now I need to look at the F prime graph and know, where is it increasing? Well, it's increasing up until about -1, maybe a little bit less than -1. You can see that right here. It's a little bit less than -1. But you can see how F prime is increasing. And so that means the slope over there is positive, so the original graph is concave up. And then all the way until about 1/2, F prime is decreasing, and that's concave down. Look at the slopes here. Steeper, steeper, steeper. F prime is decreasing when you're concave down. And so that's concave down. And then after 1/2, it starts to get steeper and steeper and steeper. And so F prime is increasing. And so that's positive. And the original graph is concave up there. I don't know, that to me this is the hardest one. So it's concave up from -infinity to -1 because the derivative of F prime is positive. And then also from 1/2 to infinity, and it's concave down from -1 to 1/2. And there's inflection points at x = -1 and x = 1/2. So those are really, really advanced questions. They're really challenging.
Yeah, they are really, really difficult.
Yeah, I don't have, to me, I like this for a study guide question. You know, remember the purpose of the study guide is not to tell you what's going to be on the exam. Like, here's the exam, I'm just going to change the numbers. The study guide is to like really challenge you to really think about it. And I like your point, Sandra. For the first ones, the ones that were a little bit easier, the key was to know the theory of where there are relative maximums, because it goes from increasing to decreasing. That's the whole point of this question. is not that this is an exam question, but it's to get you thinking about that theory. And so that's what the concavity is about too. It's not that I'm necessarily going to ask this type of question on the exam, but it's to get you thinking about like, what does concave up mean? And it means the derivative is increasing. Well, I have the derivative. And where is the derivative increasing? Here and here. So that means it's
I have
concave up there.
question.
Mm-hmm.
Okay, you just say something like when we have a concave up, f prime prime is positive, so the slope of f prime is positive. Is it any way we can see it on the graph, like we can see the f prime prime be positive, like the slope be positive?
Do
No.
you mean the graph that we have right here?
Yes.
Yeah, absolutely. Right. This is f prime.
Mm-hmm.
And so when is the slope positive? Well, look, it's increasing over here on the right. The slope is positive. So f
Okay.
prime is increasing.
Oh yeah. Are we going to have the same logic? We know that is positive when it's above the x-axis? No. Okay.
No, because so now this is like saying, what if I gave you a graph of a function? I don't want to do the same thing. So some kind of graph like this, and say this is the graph of f, and I want you to tell me where is f increasing. Well, you would say, well, there's a minimum here, wherever this minimum is, and over here, f is increasing.
Mm-hmm.
That's what we're doing for the double prime. Is we have the graph of f prime, and we want to know when is f prime increasing.
Okay.
We're just, when is it going up? That's
Okay.
all we're looking
I
for.
see.
When
I see.
Mm-hmm.
Okay, makes sense. Yeah, got it. Thank you.
You're welcome. This might be one where you go back. How many minutes in are we? We're like an hour in. You go and look at the recording and you watch this like 10-minute video again. It'd be cool if I could. I just don't have time to go in and like go back through the chat videos and like mark. Remember how like for the solution videos, I'll mark certain times for each question? It'd be nice if I could do that and mark like, hey, we went over number 14 at 1 hour and 2 minutes. You could kind of just click on that and watch us go over number 14.
Oh yeah, that would be nice.
Wouldn't that? I shouldn't have even mentioned that it's possible because I'm having a hard time keeping up with grading and everything. So I don't have time to do extra stuff like that. I'm really glad that Dr. Sugar is letting me use her videos and is posting those. I know it's like, I feel bad because it's a different style, and it's not the exact same type of notes that I have. And so it's a struggle for you. But I just would not be able to record all those videos because I'm the only instructor for Calc 3. So I'm the only one that can do those videos. So it's kind of nice that at least I don't have to record all that. All right, I think that is all the time we have. So I'm gonna stop the video and I'll post it later. Just let me know if you have other questions. If you wanna hang out, like I'll stay on, but I'm gonna end class now and stop the recording, but I'll stay on if you have any additional questions. I'm working on the exam now. As soon as we're done with questions, I'm gonna work on the exam. I'd like to have it posted by noon. It's kind of my self goal is to have it posted by noon. Yeah, I think that's it. Okay, I'm gonna stop the recording, but I will not end